Hello everyone, we are moving to section 2.7, product to sum and sum to product formulas. We're going to start with product to sum formulas. None of these three formulas I'm going to write down on the board, you will need to memorize. They're just formulas to use for solutions and to play a little bit. Our first formula is going to be how to convert the product of sine and sine into the sum of two cosines. Unfortunately, we cannot convert it to sum of anything. So sine and sine are going to produce a half of cosine of the difference minus cosine of the sum. More formulas. How to convert cosine and cosine into the sum or difference. Cosine of alpha minus beta plus cosine of alpha plus beta. And the last one is going to be a mixed product here. Sine, sine, cosine, cosine. Now we are going to have a sine and a cosine. And that's 1/2. And that's going to be sine of alpha plus beta plus sine of alpha minus beta. So, how the formulas are obtained? I'm going to prove formula number 3. So, formula number 3, proof. What I'm going to do, guys, I'm going to actually consider this part as my right side of identity and show that right side of identity is equal to the left side. So let me kind of label it as a right side of identity. Now here I have two sine of sum and sine of difference. I'm going to use the formulas on both of them from section 2.5. So I'm going to write down over here right side 1/2, and the formulas are sine of alpha, cosine of beta. It's going to be a little bit long, plus cosine of alpha, sine of beta. These are the formulas I want you to remember. Plus sine of alpha, cosine of beta, minus sine of alpha, cosine of beta, right? Because that's minus here, it's minus here, plus here, plus here. Now what I see, guys, I see the term which is going to be, I think I copied the formula here, sine of beta, cosine of alpha, sorry. Or sine of alpha, cosine of beta, sine of beta, cosine of alpha, kind of switch position of alpha and beta in sine and cosine. Now, I'm going to look at this term and at this term and compare them and see that both are having cosine of alpha and sine of beta. This has plus, this has minus, or they're going to cancel. These two terms, on the other hand, are identical. That's sine of alpha, cosine of beta, cosine of beta. So I'm going to add them and get just two of them, right? So it's 1/2, 2 sine of alpha, cosine of beta. Well, 2 and 1/2 are going to cancel, and I'm going to get sine of alpha by cosine of beta. As you see, that's exactly my left side, right? So that's the way all the formulas are proved. You just consider this, get the formulas from section 2.5 for these cosines, and also simplify them. You can do it as exercise, as an additional exercise at home. I think that makes sense to try to prove the rest of the formulas. Again, I'm not asking you to memorize them because they are very easy to obtain. For example, this formula is very easy to obtain. Just like consider the difference formulas and get the formula, okay? Okay, so, well, let's kind of solve something using these formulas. I'm going to erase my solutions from here and all the formulas. And you do have formula number 1, number 2, and number 3 probably copied somewhere in notebook. My suggestion while you are listening to my video lectures, use your notebook sometimes and copy essential stuff. So I'm going to start with example number 1, and we'll try to simplify expression sine of 6 theta, and the sine of 4 theta. So what I'm going to do, well, you see the product of two sines, right? That's formula number 1 from our set of 3 formulas. Again, you don't need to memorize them right now. You just can open the book and look at the formulas, or if you did copy them in your notes, you can look at your notes. Okay, formula number 1 is giving us 1/2 cosine of the difference. So it's a 6 theta minus 4 theta minus cosine of the sum, 6 theta plus 4 theta. Well, that's 1/2. Cosine of the difference is cosine of 2 theta, right? 6 theta minus 4. Cosine of the sum, supposed to be minus here, sorry. 6 plus 4 is 10, so it's cosine of 10 theta. Well, that's all I'm going to do. I simplify the formula. So you can try to simplify something on your own. Let's do self-simplifying. Same way. Sine of 4 theta, cosine of 5 theta. Can you simplify it? You will need to use formula number 3. I'm going to count to 3 and you can pause the video and do simplifying in your notebook. Okay, 1, 2, 3. So I'm using the formula, and that's 1/2 sine of the difference. Let me see. I'm proving the problems on that different sheet. Right. 4. Oh, sorry. Too early, the parentheses. Okay, again, I'm using formula number 3. Formula 3. Formula 3 from our list of formulas. Right, the sine of the sum plus the sine of the difference. What I'm going to have? Sine of 9 theta here. Sine of 9 theta here. Plus sine of minus theta here. 4 minus 5 is minus 1, right? Well, what I'm going to do with this minus theta, I'm going to use the fact that sine is odd function and the minus can jump outside. And I'm going to rewrite it as 1/2, sorry, not equal sign before 1/2, sine of 9 theta minus sine of theta. That's going to be the final answer. Okay, these are examples of use of these formulas. Now, guys, let's do sum to product formulas, which are going to be kind of inverse formulas when we have a sum and we are going to convert it into product. Okay, let me erase these examples and write down the formulas. Sum to product formulas. Number 1, sine of alpha plus sine of beta. 2, sine of alpha plus beta over 2. Over 2 comes in parentheses. So it's add alpha plus beta, divide by 2, and then take a sign. And then cosine of alpha minus beta over 2. Formula number 1. Formula number 2. Sine of alpha minus sine of beta. Sorry, maybe it should not be parentheses. 2. Sine of alpha minus beta over 2, and the cosine of alpha plus beta over 2. Formula number 3. Cosine of alpha plus cosine of beta. Write down alpha back. And that's 2 cosine of alpha plus beta over 2 cosine of alpha minus beta over 2. And the last formula, number 4, cosine of alpha minus cosine of beta. And that's 2 with minus sine of alpha plus beta over 2. And the sine of alpha minus beta over 2. Well, you see there are 4 different formulas and they have combination of sine, cosine, and cosines and sines. If you look at this side of the formula, you probably recognize actually the left side of the formulas before, right? That's like right side of the formulas here. I remember we had the formulas product to sum. There are products, products, products. What is the difference here? We had 3 formulas before, now we have 4 formulas. Why does it happen? Well, actually these 2 formulas, that's 1 formula, but they are given like 2 formulas because they don't want us to kind of switch pluses and minuses here. Remember we had sine, cosine was formula number 3, cosine, cosine, and sine, sine. Actually there are 3 formulas. These 2 can be combined together. Do you need to memorize them? No, guys, you don't need to memorize them. If I want you to use the formulas, I'm going to give it to you, okay? Or I'm going to ask you to obtain them. I'm going to show you how to obtain formula number 1. And it's not difficult actually, so I'm just gonna take like maybe 5 minutes. So normally, if you need them for future, you will be able to obtain them yourself. And memorizing these formulas is not gonna be any helpful to us. So I'm going to do formula number 1, okay? So what I'm going to do? Well, I'm going to actually consider this side and previous formulas, product to sum formulas. Remember, this side was part of the formula number 3, right? So I'm just going to apply formula number 3. So I'm going to call it my right side, and I'm going to write down that right side, use formula 3, is going to be equal to 1/2, right? The formula tells. Well, this 2, I'm going to put it in front. And then instead of sine product cosine, I'm going to have in parentheses sine of alpha plus beta, right? So I'm going to consider this as my alpha, and this is my new beta. So I'll need to add them once in a sine and then subtract them. I'm going to start adding them. Alpha plus beta over 2 plus alpha minus beta over 2. And then plus sine of alpha plus beta over 2 minus alpha minus beta over 2. So here I'm going to cancel 2 and 1/2. And this one, if you look at these two fractions, they do have same denominator, so I just can add numerators. What I see, I have beta with plus, beta with minus, and there are 2 alphas. If you add alpha plus alpha, 2 alphas, divide by 2, just alpha. So I'm going to just have sine of alpha instead of the whole expression here. Here I'm going to open parentheses. It's not going to be that like simple. Alpha plus beta minus, because minus happens in front of the whole thingy, I'm going to have alpha plus beta, because minus distributed to alpha is going to give you minus, and distributed to beta is going to give you plus beta over 2. Well, sine of alpha plus, what here is going to cancel is alpha, right? Because it's positive alpha, negative alpha. Beta is going to be doubled, divided by 2, and I'm going to get sine of beta. Not very difficult. But yes, you do need to remember formulas from section 5. Remember, I was asking you to memorize 2 formulas. One for sine, a sine of cosine, sine like this one, right? And one for cosine. Okay, so that's a proof. Let's kind of use it somewhere, and I'll ask you to do 1 or 2 solve problems, okay? So let me erase this. Use a different marker. So I'm going to consider example first, example 2. Sine of 5 theta minus sine of 3 theta, right? That's a sum. I'm going to convert it into product. So what I'm going to have, choose, that's a difference of signs, right? If you look at the table of the formulas, we have a sum of signs, we have difference of signs, sum of cosines, and difference of cosines. So that's formula number 2. I'm going to write down formula 2 from the table of 4 formulas, right? So the difference of signs is going to be 2 sine of the half difference, 5 theta minus 3 theta over 2, and the cosine of half sum, 5 plus 3 over 2. Well, I'm going to simplify this, and that's going to be sine of 5 minus 3 is 2. 2 theta over 2 is going to give me just theta. And the cosine, 5 plus 3 is 8, over 2 is 4 theta. And that's going to be my final answer. I did simplify everything. Now guys, I'm going to put 3 problems on the board for your kind of practice. And of course, I'm going to solve the problems myself, but I want you to stop the video and practice with these 3 problems first, okay? So I'm going to raise my example number 2 and the name of the section. I have more space to put my problems on the board. So problem A, cosine of 3 theta minus cosine of 2 theta. Problem B, cosine of theta plus cosine of 3 theta divided over 2 cosine of 2 theta equals cosine of theta. This is identity to prove identity. And C, sine of 255 degrees minus sine of 15 degrees. Well, also simplify. So, simplify, prove identity, and simplify next one. What I'm going to do? Well, I'm going to count 1, 2, 3. You can stop the video and try to do it on your own. So 1, 2, 3. I'm going to start with problem A. Well, problem A, remember we had 4 formulas. Sine plus sine, sine minus sine, cosine plus cosine, and cosine minus cosine. So that's going to be formula number 4. Cosine of 3 theta minus cosine of 2 theta. Formula number 4. Formula 4. Okay, I don't have that. Right. Formula 4. Okay, for formula 4, we are going to get minus 2, right? And they're going to be sine of the sum by half sum by sine of half difference. So it's 3 theta plus 2 theta over 2. And the sine of 3 theta plus 2 theta minus 2 theta, sorry. Minus 2 theta over 2. Well, let's simplify it. Minus 2. And here we have what? 3 plus 2 is like 5 over 2. It's going to be sine of 5 theta over 2. And here we have 3 minus 2, which is 1, right? 1 theta over 2 is going to be just sine of theta over 2. Not much of simplifying it, just like a use of the formula. Okay? To prove identity, I think I'll need the whole board. So I'm going to move to question C, because question C is like shorter one. That's just use of the formula. And it's still going to fit over here. And then erase everything and do question B, okay? For question C, you see the difference of 2 sines, right? Difference of 2 sines, that's formula number 2. Sine of 255 degrees minus sine of 15 degrees. Formula number 2. Again, of these 4 formulas, we did the second part of the formulas, right? And what is going to be? 2 sine of half difference, 2 sine of half difference, so 255 minus 15 over 2 by cosine of half sum, 255 plus 15 over 2. Degrees here, sorry, missing degrees. Well, not supposed to be too difficult. So 255 minus 15, it's going to be like, what? 240 over 2. Sine of 240 degrees over 2, right? And the cosine, we have 255 plus 15. That's going to be 70 degrees over 2. I'm going to simplify this expression a little bit more. I'm going to divide by 2 here and get 2 sine of 120 degrees, and the cosine is going to be of 135 degrees, right? If you divide 270 over 5. Well, actually these two are not table values, but can be reduced to table values. So that's sine of 2 pi over 3. It's supposed to be equal to the sine of pi over 3, and that's equal to what? Square root of 3 over 2. The cosine of 135, well, I don't have space here, but 135 is something like this. If you add actually here 45, you get 180. So that's angle 135. The cosine is going to be somewhere here, and that's going to be same as a cosine of 45 degrees. 135. But we're going to have a minus, right? So minus 1 over square root of 2. And this 2 in front cancels minus a square root of 3 over square root of 2. And that's going to be the final solution. You can combine these two square roots together. You can rationalize it, but that's going to be the final answer. Okay, now I'm going to move to prove identity. I'm going to erase my other problems. I'm going to erase problem C. Problem is, so I'm going to leave only identity. Well, it's not going to be a big proof actually. I'm just going to use a formula. And so what I'm going to do, guys, well, I'm going to consider my left side of identity and try to develop it left side. So that's a formula, right? The sum converted into the product. Formula number 1, number 2, number 3, or number 4. We remember that first two formulas are about signs, sine of sum, sine of difference, and then the cosine of sum and cosine of difference. So that's what I'm going to do. I'm going to use actually that formula number 3, and formula number 3 is going to give me 2 cosine of half sum, theta plus 3 theta over 2, by cosine of half difference, theta minus 3 theta over 2. I'll need to divide by my denominator, 2 cosine of 2 theta. I can cancel this 2 and 2. And what else? I have theta plus 3 theta. It's 4 theta over 2 is going to give me theta over 2. So that's a cosine of 2 theta. 2 theta, right? Cosine of 2 theta here in denominator. And this one is going to be the cosine of minus theta minus 3 theta is minus 2 theta over 2, which is minus theta, so cosine of minus theta. This and this expression is going to cancel, and for cosine of minus theta, I'm going to use the fact that cosine is even function. Even function means that the argument having minus is going to just be the same as argument without minus, and I proved my right side. That's it for our section 2.7. Do your homework, and that's not all Wednesday lecture because it's a little bit too short. I'm going to teach one more section, but I'm going to do it a separate lecture. Guys, I want to say 2 words about the quiz. I assume that you do quiz with just piece of paper and your pen or pencil calculator like we do it in class. Well, of course I cannot check this, and maybe almost everyone is using the book, using the notes and everything. But if you use formulas from the book, you have to prove them, because we do have a certain amount of formulas which I'm asking you to memorize. And for example, formula for sine of pi over 12 was not among them. You obviously copied it from the book, and if you copy it from the book, I'll need a proof, okay, to consider it as a part of correct solution. My goal on quizzes is to check what you learned, is not to check what you can copy from the book or from internet. Okay? Okay, keep working, and I'm going to make a second part of the lecture a little bit later. Thank you.